In the time it takes you to blink, an AI agent can write 10,000 lines of code. Not pseudocode, not boilerplates, real, functional, deployable code, complete with error handling, unit tests, and documentation. An entire banking backend generated in seconds. Um, Machine learning pipeline built in the time it takes to make coffee. A complete microservice architecture with authentication, login, and deployment scripts created before you finish reading this sentence. The implementation singularity, the concept of implementation singularity isn't coming. It's already here. The machines can now generate production ready code faster than any human team can type, faster than any project manager can write tickets, faster than any architect can draw diagrams. But here's the question nobody is asking, and it's the most important question in software engineering today. Is it the right code? Is it the right code? Speed without intent is just noise. And we have built a very fast noise machine, AI. A very fast noise machine. Let me show you what I mean. Consider this. A single AI agent given the prompt, build a banking application, produces 10,000 lines of functional code. The code compiles, all 312 unit tests pass, the linter reports 0 issues, the coverage report shows 98%. By every metric we use to measure code quality, this code is perfect. But here is a problem buried in line 4712. The authentication middleware does not validate token expiration. Any token, once issued, works forever. This is not a bug that tests will catch, because the test checks that valid tokens work. And they do in this case. They work forever. This single missing check means that any stolen session token grants permanent access to every account in the system. The AI did not know to check this. It cannot know, because knowing requires understanding why we authenticate users in the first place. And that is a question about human intent, not code syntax. Right? Human intent, not code syntax. This is the story we need to tell. Not a story about what AI can do. That story has been told 1,000 times and over, 10,000 times and over. We've told the story of what AI can do. But this is a story about what AI cannot understand. The gap between code that works and code that should exist in the first place. Give an AI agent a complex request, build a bank, and watch what happens. It decomposes the problem with breathtaking efficiency. Authentication service, account management, transaction processing, notification system, deployment infrastructure. Each branch splits further into substacks: login API, OAuth integration, JWT token management, session handling, password hashing, two-factor authentication. The tree grows deeper and wider until every conceivable implementation detail has been mapped, which I guess is excellent, right? And the AI sees only the technical requirements. It does not ask about the business model, the regulatory environment, or the competitive landscape. It does not wonder who the customers are, what their risk tolerance is, or whether this bank should even exist in the first place. No, it doesn't. And then it solves them. It solves the problem regardless, all of them. In minutes, not months. Every task in the tree turns green. Every checkbox gets ticked. Every unit test passes. The progress bar reaches 100%. The AI reports task complete with the same confidence whether it has built a masterpiece or a catastrophe. But wait, look at what's missing. It solved the what, the implementation checklist, but nobody asked about the why. The what that it can solve and the why. It solved the what. Why are we building this bank? What regulatory constraints apply in this case? Which jurisdiction governs our operations? What happens when the system fails at 3 a.m. on a holiday weekend and there's no one awake to respond? Who is liable when a customer's money disappears? The AI didn't ask these questions because it fundamentally cannot. It fundamentally lacks the ability and the capacity to ask these specific why kind of questions. It has no mechanism to question the goal itself, no ability to step back and say, I think we are solving the wrong problem. It only knows how to decompose and execute. It operates in the what space, the implementation checklist, while the most critical decisions live in the why space, which is the strategic intent. Let's zoom out and trace the evolution of the developer through the decades. This tells a story that most people in the industry have not fully internalized yet. In the 1950s, programmers were builders in the most literal sense, feeding punch cards into machines, toggling switches, physically constructing the logic one instruction at a time. The human was the computer. By the 1990s or thereabout, developers had become craftsmen equipped with powerful IDEs, the VS Code, but not as early as then, the IntelliJ IDE, Notepad, as the case may be, powerful IDEs that provided syntax highlighting, autocomplete, and sophisticated debugging tools. The tools amplified human capability, but the human remained firmly in control of every decision. In 2021, GitHub Copilot arrived, and the paradigm shifted fundamentally. Suddenly, the developer became a reviewer. The AI suggests entire functions. The human accepts or rejects. The developer no longer writes code from scratch, but instead curates, edits, and approves machine-generated solutions. A fundamental transformation from writing to reading. And now we have entered the era of agent swarms. Multiple AI agents collaborating autonomously, planning, researching, coding, testing, and deploying with minimal human intervention. The human is no longer the builder, the craftsman, or even the reviewer. It has gotten to the extent that the developer is no longer the reviewer. We can get to that. You may wonder, how is that the case? Because the volume is so much that it's not valid if you claim that the developer is the reviewer at the scale at which AI is able to produce this code. The human has become the supervisor watching from above as the machines do work. But how? But what does the supervisor actually oversee? Guess what? Not the code itself. There's too much of it. The supervisor oversees the intent. So, we have long passed the phase where the developer has to even just review the code. It's over with the code. It's now about the intent. The supervisor, the developer this time, ensures that the machines are building the right thing. One, for the right reason. Second, third, in the right way. And that is a fundamentally different skill than writing code. The question is no longer, can the code be written, but should it be written? We've moved from implementation to intent. We've moved from implementation to intent. From typing to thinking. From building to deciding. And that changes everything about what it means to be a software engineer. Think about that question. Does speed equal intelligence? Does speed equal intelligence? Think about that question for a moment. Does skill equal intelligence? We have built systems that can generate code at superhuman speed. But speed of execution is not the same as depth of understanding. A calculator can multiply faster than any mathematician, but it does not understand mathematics. Here's something that actually happens every single day in software development teams around the world. An AI agent builds what appears to be a perfect architected system. The architecture diagram is beautiful. An API gateway feeding into an auth service connected to a database with a cache layer and a message queue for async operations. The code is clean, modular, well documented, and every component follows best practices. Every test passes. Every linter is happy. The code review would impress a senior engineer. This is genuinely impressive work. By any conventional measure of software quality, this code is excellent. But the auth service has no rate limiting, meaning an attacker can attempt millions of password combinations per second. There's no brute force protection, so a determined attacker will eventually guess any password. Session tokens never expire. Once stolen, they grant permanent access. The encryption uses a deprecated algorithm known to be breakable with modern hardware, and the error message leaks internal system details right to the front end, giving attackers a roadmap of the infrastructure. The AI never asked about security requirements because nobody told it to. It was asked to build an auth service, and it did. Beautifully, technically, flawlessly, but without any awareness of the threat landscape it would face in production. It implemented authentication without understanding why authentication exists. When a security team finds these issues, and they will, the response is always the same. But all the tests passed. Yes, yes, AI tested, which is that the code does what the code does. The test did not test what the code should do, which is protect real users from real attackers with real consequences. This is the bridge to nowhere. The structure is sound, the engineering is impressive, but it leads somewhere nobody wants to go. A technically correct solution bets to the wrong problem. A technically correct solution bets to the wrong problem. The AI doesn't know what it doesn't know. It cannot ask, what about compliance? Because compliance isn't in its optimization function. Guess what is in AI's optimization function? Not compliance, but rather execution. Modern AI agents use a deceptively simple loop: plan, execute, observe, and repeat. This is the reasoning engine that powers every major AI coding assistant. Plan, execute, observe, repeat. Plan, execute, observe, repeat. When the task is well defined, sort this array, pass this CSV, implement binary search, this loop works beautifully. Plan, execute, observe, repeat works flawlessly for this type of well defined task. The plan is clear, the execution is precise, the observation confirms success, and the loop converges efficiently on a correct solution. For these kinds of tasks, the AI is genuinely superhuman. There's no argument about that. But when business context is missing, the loop becomes something far more dangerous than broken. It becomes confidently wrong. It optimizes without understanding. It iterates without questioning. It plans the how with extraordinary precision, but it cannot question the why. The loop does not know and does not have a step that says, wait, should we be doing this at all? The why. Should we be doing this at all? Consider what's required but missing in most AI generated code: business context. Why does this feature exist? Who requested it? What problem does it solve? Domain constraints. What are the rules of this industry? What regulations apply? What are the failure modes that domain experts know about? Regulatory requirements: GDPR, HIPAA, SOX, PCI DSS, each with hundreds of specific technical requirements that must be woven into the code. And user intent, the fundamental why that justifies the entire project's existence in the first place. Without this context, the loop executes perfectly on the wrong objective. It builds what you asked for, not what you needed. And because it builds with confidence, because every iteration reports progress, because every log entry says step completed successfully, nobody notices until it's too late. The AI doesn't fail loudly with an error message and a stack trace. It fails silently, delivering code that compiles, that passes tests, that deploys successfully, but that should not exist in the first place. A confident wrong answer delivered at a machine speed is far more dangerous than an obvious error. Far more dangerous. There's a concept in risk management called skin in the game. Skin in the game. When you hear a business person say, that guy has no skin in the game, it means the person making decisions should bear the consequences of those decisions. The trader who bets with their own money makes better decisions than the one who bets with someone else's. The surgeon who operates on their own family pays closer attention than the one who does not know the patient. In AI assisted coding, there is a profound asymmetry. The AI makes the decisions about architecture, about security, about data handling, but the human bears all of the risks. Every legal consequence, every financial penalty, every career ending moment falls on the human, not the machine. Let me show you what that looks like. Below the rope lies the chasm: financial ruin from regulatory fines and breach costs, lawsuits from customers whose data was exposed, career destruction for the engineers who deploy the code. Everything that happens when software fails in production falls into this void. The human walks the tightrope every single day. The sign off on an AI generated code, the review pull request they cannot fully understand, the approved deployment of systems too complex to fully test, and they carry the AI as a balancing pole, a tool that helps them move faster, but that also introduces instability they did not alter. The AI is the pole, it helps with balance, it provides suggestions and completions, it generates code at astonishing speed, but it does not fall. When the pole shifts, it is the humans who loses their footing. It is the human who plunges into the chasm. The AI remains exactly where it is, unchanged, unaffected, unaccountable, no skin in the game. Every time the AI generates code with a subtle bug, every hallucinated function call, every incorrect assumption about the database schema, the pole shifts and the human has to correct their balance. The problem is that these shifts are invisible. The bug compiles, the test passes, the error is silent. If the pole shifts too far, the human falls, not the AI. The AI cannot be sued. The AI cannot be sued, cannot be jailed, cannot be fired, cannot lose its medical license. The AI cannot lose its medical license or its engineering certification. It has no reputation to protect. The AI has no family to support. AI has no professional liability insurance. AI has no skin in the game. And that changes everything about the quality of its decisions. This is the fundamental asymmetry of AI assisted software development. The machine makes the choices about security, architecture, and data handling, but the human pays the price when those choices are wrong. And the price is not metaphorical, it is measured in dollars, in prison sentences, in careers that end overnight. On August 1st, 2012, a company called Knight Capital Group developed a software update to their algorithm trading system. In 45 minutes, the software had lost $440 million in 45 minutes, effectively destroying the company overnight. A 30-year-old firm with 1,500 employees gone because of a code deployment that nobody fully reviewed. That's far back 2012. Now imagine that same scenario, but the code was written by an AI agent. that was never told about risk limits or circuit breakers, that was never informed about position, sizing, or a maximum loss threshold. This is the speed of failure. And in the age of AI coding agents, the speed has only gotten faster. The terminal is live. The algorithm is running. Every second it makes dozens of trades, buying and selling millions of dollars in stock at a speed that no human trader could match or even monitor. The algorithm does not hesitate, it does not second guess, it does not feel the weight of the money it is moving. It has no skin in the game. Each line is a trade, each trade is a bet, and the algorithm is making these bets faster than any human could read them, let alone evaluate them. The buy is executed before you can process the sell. The sell is reversed before you notice the loss. This is execution without comprehension because it has no skin in the game. Watch the losses. Watch the losses accumulate in real time. This is what happens when speed operates without judgment. $1 million in 3 seconds. $1 million in 3 seconds. And the algorithm sees no problem. The tests are passing. The code is executing correctly. By every technical metric, the system is functioning perfectly. 5 million and the algorithm is still running, still executing its plan, because plan, execute, observe. Remember, the plan says trade, the execution trades. The observation sees that the trade executed successfully, so the plan continues. There's no step in that loop that asks, should we stop? Because it has no skin in the game. There's only one thing that can stop the bleeding: an emergency stop button. But who presses it? The algorithm will not press it for itself. The logs look clean. The tests are passing. The system is running exactly as designed. The catastrophe is invisible to the machine. The AI will not press it. The AI does not understand consequences because it has no skin in the game. It does not feel the weight of $400 million. It does not know that families depend on this company. It has no skin in the game. It has no family. It does not know that 1,500 people will lose their jobs. It has no skin in the game. And without skin in the game, there is no fear. The AI agents have no fear. And without fear, there's no caution. The speed that makes AI so powerful is the same speed that makes it so dangerous. A human writes code that may be 50 lines per hour. An AI writes 50 lines per second. But mistakes at that speed compound at that speed. They compound at the same speed. Errors at that speed cascade through systems faster than any human can react. And the gap between the mistake and the consequence shrinks to zero, almost instant. The lesson of Knight Capital from far back is not that algorithms are dangerous. It is that algorithms without human oversight are catastrophic. The technology was not the problem. The absence of a human with the authority and the judgment to say stop was the problem. And that is exactly the lesson we need to carry into the age of AI coding agents. There are two realities in AI assisted software development: the reality the AI sees and the reality the world sees. The AI lives in a world of tests and metrics, of compilation results and deployment statuses. And between that world and the real world is a chasm that can swallow careers, companies, and lives. Let me show you both realities side by side. On the left, what the AI reports, the metrics in it tracks, the success criteria it understands. On the right, what actually happens in the real world months after deployment. On the left, generation. This is the AI perspective, the world of code compilation, test results, and deployment status. This is the world the AI was designed to optimize for. And within this world, it performs beautifully. Code compiled cleanly, no syntax error, no warnings, no deprecation notices. The static analysis is clean. Test passed. All you need test pass. 100% coverage on the generated code. Every edge case the AI could identify is handled. Deployed. The application deploys to production without errors. The health checks return 200 OK. The monitoring shows normal CPU and memory usage. Task complete. The AI reports task complete and moves on to the next request. It has no concept of what happens after deployment. It has no mechanism to wonder, did this actually solve the problem? No, because it has no skin in the game, because it lives in a different realm, in a different reality than the reality of the real world. Now look at the right side, verification. This is the human reality, the world of security audits, compliance reviews, regulatory inspections. This is what the humans go through. Even after AI says it's done, we go through the world of security audits, the compliance reviews that come in every now and then, regulatory inspections, and legal consequences, real consequences facing real people, not AI agents. This is the world that the AI cannot see, and it is the world where the real damage happens, not in the world of the code and the compilation and the tests that pass in the code. Security audit. Was the code reviewed for SQL injection? Was it reviewed for cross-site scripting? Was the code reviewed for authentication bypass? Was the code reviewed for session fixation? Nobody checked because the AI said all tests passed and we trusted it. Compilation review. Does the code comply with GDPR, HIPAA, SOX, PCI DSS? Nobody asked because the deployment was successful and the metrics looked good. Performance testing. Can the system handle 10,000 concurrent users? Will it crash on the load? Will the database connections pull correctly under pressure? Nobody tested beyond the AI generated unit test. Lawsuits filed. 6 months later, a data breach occurs. 300,000 user records exposed. The company is sued. The engineers are named in the compliance. The board demands answers and nobody can explain how the code got to the production without a security review. And when the lawsuit is filed, when the breach is discovered, who is held liable? Not the AI. The AI has no legal standing. AI agent has no bank account, no career to lose. The AI cannot be subpoenaed, cannot be deposed. The AI cannot be cross-examined on the witness stand. Liability falls on the humans who deployed the code, who trusted the metrics, who believed that task complete meant problem solved. Task complete and problem solved are not the same thing. The AI can tell you the code works, but only a human can tell you the code is right. The AI can tell you the tests pass, but only a human can tell you the right tests were written. And if it was not the right test that was written. And that difference is where accountability lives. That difference is where careers are made and lost. Who goes to jail when the code fails? Who goes to jail when the code fails? That is the question. No one in Silicon Valley wants to answer that question But someone will have to. Because when AI generated code causes harm, when a system fails and people suffer, some human will stand in a courtroom and be asked, were you responsible? The role of the software engineer is changing, and it is changing faster than anyone expected. We are moving from an era of writing code to an era of verifying code. From creation to curation, from authorship to auditing. And this shift demands an entire new set of skills. Imagine an ocean of code, millions of lines generated every day by AI agents, flowing through deployment pipelines at a pace no human team could match. The human can no longer write all this code, but someone has to read it. Someone has to verify it. Someone has to find the one bug, the one vulnerability, one in a million lines, the one logic error that will bring everything crashing down. Look at the scale of it. Row after row of machine generated binary. Each line potentially hiding a vulnerability, a logic error, a resource leak, a ticking time bomb. The human eye was never designed to scan code at this volume. No, not at this volume at which AI agents are able to generate them. The human eye and the human brain is not designed to review code at that pace. And yet, that is precisely what we are asking human engineers to do. Somewhere in this ocean of generated code is a single critical flaw. Just one line of flawed code is enough to bring everything down. Just one. Somewhere is a single critical flaw. It might be SQL injection vulnerability that allows an attacker to dump your entire database. It might be a race condition that only manifests on that peak load on Friday afternoons. It might be a logic error in your pricing engine that gives away products for free. The AI that wrote this code cannot see the flaw. It passed all the tests. It compiled cleanly. The deployment succeeded. Remember, task complete. But the flaw is there, hiding in plain sight, waiting for the right conditions to detonate. Now enters the auditor, the new human role in software development. Not the writer, but the verifier. Not the coder, but the guardian. The person whose job is not to create software, but to make sure that what the machine creates is actually safe, actually correct, actually worth deploying. The auditor stands on the lighthouse, scanning the ocean of code with a searchlight, looking for the one flaw that will bring everything down. Looking for just that one flaw. This is patient work. This is meticulous work. This is the work that separates competent engineering from catastrophic deployment. The auditor found what the AI could not see because the auditor understands what? Context. The auditor knows what the code is supposed to do, not just what it does, what it's supposed to do. That's the context. That is what is critical now as a skill for software engineers. The auditor asks, will I stake my career on this code working correctly? And that question is something no AI can ask itself. Which AI model will ask itself, will I stake my career on this code working correctly? No, because they have no skin in the game. This is the future of software engineering. Not writing code, but reading it. Not generating, but verifying. Not creating, but curating. The human becomes the auditor. The human becomes the quality gate. The human becomes the last line of defense between machine generated code and the users who depend on it. If AI is generating the code and humans are verifying it, we need to define exactly how that relationship works. Where does the AI stop and the human begin. There are two dominant paradigms, and they represent fundamentally different philosophies about trust and control, about how much autonomy you give the machine and how much oversight you retain. The first is called human in the loop, and the second is called human on the loop. The difference between them is the difference between a pilot flying a plane and an air traffic controller watching a radar. One has their hands on the controls at all times, the other watches from a distance, trusting the system until something goes wrong. Human in the loop, the human is directly embedded in every step. The AI generates code, the human reviews it line by line. The AI revises based on the human's feedback, the human approves the final result. Nothing ships without explicit human sign off. No deployment happens without a human saying, this is correct, this is safe, this is ready. This is slow, it is deliberate, and it is safe. Slow, deliberate, and yet safe. Every line of code passes through human judgment before it reaches production. Your trade speed, you trade speed for confidence, you trade throughput in code generation for accountability, and for high stakes systems, that trade-off is not optional, it is mandatory. In mission critical systems, it's mandatory. Now, human on the loop. For human on the loop, the AI operates autonomously. It plans, it executes, it reports. And the human monitors from a distance, only intervening when something goes wrong or when the metrics cross a threshold. This is how most autonomous vehicle systems work. The car drives itself, the human watches and grabs the wheel when necessary. This is fast, it is efficient, and yet it is what? Dangerous. The human trusts the AI to make good decisions and only steps in when alarms goes off. But what if the alarms are wrong? That's what is wrong with this approach. That's why you need the human in the loop approach, not the human on the loop. But I guess majority of those who are vibe coding nowadays and companies that encourage it are only concerned about the human on the loop, not human in the loop, because they are just concerned about the speed and the throughput, how fast code is generated, which is very, very dangerous. Because again, if you wait for the alarms, what if the alarms are wrong? What if the AI does not know it is failing? What if the monitoring metrics look green while the system is silently corrupting data? The Tesla autopilot crashes taught us that on the loop only works when the human actually pays attention. So which one do you choose? The answer is not one or the other. The answer depends on what is at stake. What is the cost of failure? Who is affected? How many people could be harmed? The stakes determine the workflow. Is it a blog post? On the loop is fine. Just let it go on and on. When something goes wrong, we come in and fix it. It's a blog post. A personal website, on the loop is also fine. Let it just run. If something goes wrong, we'll just fix it. It's just a website. But a payment processing system must be in the loop. Always. Every line of code, it has to be human in the loop, not human on the loop. Always. A medical device in the loop with regulatory review. A self-driving car, it has to be human in the loop, not on the loop, and in the loop with real-time monitoring. The higher the stakes, the tighter the human grip must be. The more lives at risk, the less autonomy the machine should get. The choice between these two workflows is not a technical decision, it is an ethical one. Consequences are the reasons why It has to be an ethical one. It is a decision about how much risk you are willing to accept and who bears the consequences when that risk materializes. It is a decision that should be made consciously, deliberately, and with full awareness of the stakes involved. We have established that humans must remain in the loop, that they must verify and audit AI generated code. But there is an even more powerful approach than verification after the fact. How do you prevent the problems in the first place? How do you encode human intent into the AI workflow before the code is even generated? Before the first function is written? Before the first test is defined? The answer is context engineering. The art of writing rules, guardrails, and constraints that shape AI behavior before it writes a single line of code. This is proactive rather than reactive. You define the boundaries upfront rather than discover violations after deployment. So this kind of takes care of the fact that though in the loop, human in the loop is preferred and better, it is not that easy because of the volume that gets generated by AI, right? So this helps to take care of that. There is a way to bring the engineering context in, right? Bring the engineering context in. So it's kind of working smart in doing human in the loop. In practice, this looks like a configuration file, a .cursor rules file, a system prompt, or a project level rules document that tells the AI exactly what boundaries it must operate within. Think of it as a constitution for your AI coding assistant. So you have the cursor rules, you set for security, you require odds, you require rate limiting and all that. The file name itself is a declaration of intent. These are the rules the AI must follow. These are non-negotiable constraints. Security constraints are listed first because they are the most critical. Every API endpoint must require authentication and rate limiting. No exceptions, right? These two rules alone would have prevented many of the security disasters we discussed earlier. No hard-coded secrets ever. This single rule prevents the most common security vulnerability in AI generated code. Secrets that get committed to version control and exposed to the world. Business logic constraints encode domain knowledge that the AI would never discover on its own. Maximum transaction size, say $10,000. This is a guardrail that prevents the AI from generating code that could process unlimited transactions. A simple rule with enormous protective power. Two-factor authentication for all financial transfers. This is a compliance requirement that the AI would never include unless explicitly told. Think of this file as a shield, right? An intent guard. It stands between the AI and production, protecting the code base from the AI's worst impulses, encoding human judgment into machine readable rules, turning experience, wisdom, and caution into constraints that the AI cannot violate. Without guardrails, the AI guesses at context. It makes assumptions about security, about business rules, about user expectations, and those assumptions are where the bugs live. I repeat, the assumptions that AI makes about these things are where the bugs live. Those assumptions are where the breaches start. Those assumptions are where careers end. Context engineering is the art of encoding human intent into machine readable constraints. It is the new primary skill of the software engineer. Not writing code, but writing the rules that govern code generation. Not implementing solutions but defining the boundaries within which solutions can exist. The engineers who master this skill, who can articulate business requirements as machine constraints, who can encode domain knowledge into guardrail files, who can translate regulatory. The engineers who master this skill, who can articulate business requirements as machine constraints, who can encode domain knowledge into guardrail files, who can translate regulatory mandates into configuration rules. These are the engineers who will thrive in the AI era because they can speak both languages, the human and the machine language this time. The guardrail file is not just a configuration, it is a contract between the human and the AI. It says, I trust you to write code, but only within these boundaries. And if you violate these boundaries, I will know and I will intervene. Because that is what accountability looks like in the age of autonomous code generation. Now, we have talked about code generation, about verification, about guardrails, about context engineering, but there is a problem that no amount of engineering can solve. A problem that is fundamentally and irreducibly human. The problem of human disagreement. The problem of human disagreement. In every organization, there are stakeholders with contradictory priorities. The CEO wants speed and market share. Legal wants compliance and risk mitigation. Product wants features and user satisfaction. Finance wants cost reduction and headcount optimization, and AI stands in the middle of all of it, frozen, unable to reconcile these contradictions. The CEO demands speed. Ship it now. Market share is everything. Every day we delay is a day our competitor are gaining ground. Legal says, is this compliant? Can we be sued? What about GDPR? What about SOX? What about the regulatory landscape? We cannot afford another audit finding. Product says, users want this feature they have been asking for months. They do not care about your process, they care about functionality. Shipping is the priority. Finance says, cut costs, reduce headcounts, automate everything. Why are we paying engineers when the AI can write the code itself? These demands are contradictory. Ship now but make it compliant. Add features but cut costs. Move fast but do not break anything. The AI receives all these instructions simultaneously and it cannot prioritize. Because prioritizing requires understanding human politics, human relationships, human power dynamics, and human values, none of which exist in any training data sets. You don't have in AI training data sets the understanding of human politics, human relationship, human power dynamics, and human values. You don't have that in AI training data sets. The AI freezes because it cannot prioritize between contradicting instructions. It does not understand that the CEO outranks the product manager, but legal can override everyone. Or that the quiet person in the corner of the boardroom sometimes has more influence than the loudest voice. This is where the human engineer becomes essential, not as a coder but as a mediator, a translator, a diplomat between human chaos and machine precision. The engineer speaks both languages, the language of human ambition and the language of machine precision. This is where the human engineer becomes essential, not as a coder but as a mediator, a translator, a diplomat between human chaos and machine precision. The engineer speaks both languages, the language of human ambition and the language of machine precision. The engineer listens to all stakeholders, absorbs their contradicting demands, identifies the true priorities beneath the political posturing, and then translates those priorities into a coherent, specification that the AI can execute with clear, unambiguous ordering. This is the interface paradox. The AI is powerful enough to generate any code, but powerless to decide what code should be generated. That decision requires human judgment, human politics, human accountability, and human wisdom. Human wisdom about what matters most, and that is not a limitation of the technology, that is a feature of the human role. The engineer is the interface, the bridge between what humans want and what machines can do. And that role is not going away. The engineer is the interface, the bridge between what humans want and what machines can do. And that role is not going away. As AI becomes more powerful, the need for human mediation does not decrease. It increases because the more powerful the tool, the more important the judgment about when and how to use it. More power, more responsibility. Picture a server room, rows of human machines processing millions of requests per second, generating code, deploying applications, making decisions at a speed and scale that would, have been unimaginable a decade ago. This is the engine of the modern world, and it runs without sleep, without rest, without hesitation. But who is watching? Who is making sure that this engine is running correctly? That the code it generates actually serves human interest and not just machine efficiency? Who is asking the question, should we be building this? Not just can we build this? We no longer sit at keyboards typing code line by line, function by function, class by class. That era is ending. The machine can write code faster and more accurate than any human ever could. And they will only get better. Yeah, they will only get better. Our job is to stand watch, to verify, to audit, to ensure that the code the machine writes serves human purposes, human values, human interests. We are the conscience that the machine lacks, the judgment that the algorithm cannot compute. Intent is the key word. The AI has no intent. It has instructions, it has patterns, it has training data, but it does not have intent. Only humans have intent. Only humans can say, this is what we should build, and this is why it matters, and this is who it serves. And as that realization sinks in, something shifts. The cold blue light of the machines begins to warm. The servers are still running, the code is still flowing, but the atmosphere changes. Because someone is watching now. Someone is taking responsibility. The machines are still powerful, still fast, still capable, but they are no longer unsupervised. The human has reclaimed the center of the process. The guardian stands watch, and the machines serve human instincts. Not the other way around. That is the future we must build. That is the future we must build. We are the guardians of intent. Remember that phrase. Carry it with you. Because when the code fails, and it will fail, when the system breaks, and it will break, someone has to answer for it. And that someone is you, the human, not the machine. The code is easy. Yes, the code is easy, but the responsibility is hard. The code is easy, but the responsibility is hard.